Hi, I'm hw5q2. This is a video explanation for my question 2 of homework 5. In this question, the first part is to draw the non-zero definition region of the function. The function is given above, and we are given the range of y and x. We need to draw it out. Here is x and y. First we need to draw the function that x equal to 1 divided by y, like this. And the function that x equal to y here is 1, and here y equals to 1, 2. And y is less than or equal to 1. X is between the two lines. So this is what we need. The second part is to find a so that the function is a valid joint density function. You can get the function is 1 divided by a times y squared and times x. To make sure it's a valid joint density function, we need to make sure that integral from 1 to infinite, then integral from 1 divided by y, this is the range of x to y, then a y squared times x dx dy equal to 1. So we need to calculate the integral from 1 to infinite, and then integral from y divided by y to y, a times y squared times x dx dy. We need to calculate it first. So that we can it's equals to from 1 to infinite, and times a 1 divided by a times y squared, and from integral from 1 divided by y to y, and 1 over x left dx dy. Which is from 1 to 0, 1 to infinite, a times y squared. The middle part will be ln y divided by ln 1 over y dy. Which is 2 divided by a from 1 to infinite ln y divided by y squared dx. To calculate this, we need to convert let w equal to log y, let y equal to e to the power of w. Then it will be converted to like this from 0 to infinite. W e to the power of double w, w to w, then dw. Which is from 0 to infinite, w divided by e to the power of 2 times w, and times aw dw, which is like minus 2 over a from 0 to integral from 0 to infinite w d e negative w. Let it equal to 1. We can get a equals to 2. Let's do the third part. We need to find and draw the marginal density functions fx and fy. Fx and fy. Let's find the density function fy first. Fy equal to integral from negative infinite to infinite fxy dx, which is from 1 over y to y, and the function is 2 times y squared x which is log y divided by y squared times 2, where y is larger than or equal to y 1, but less where y is larger than or equal to 1. And it will equal to 0 otherwise. Now we can get draw it from y, y. Oh, here is no 2, sorry. When y equal to 1, it will be 0, and it look like this. Then we find the density function of x. It's from integral from negative infinite to infinite fxy dy. Which is from which is from infinity to 1 over x times 1 divided by 2 times y squared times x dy, which is there are two conditions. Each equals to 1/2 when x is larger than 0 but less than 1, and each equals to 1 divided by 2 times x squared when x is larger than 1 but it's larger than 1. So we can draw it now. Here is 1 over 2. Here is x, and it keeps the 1 divided by 2 before 1, and it will be close to 0 when it's going to infinity. The last part, we need to verify fx and fy are both valid density functions. We need to calculate from 1 to infinite fy dy equal to from 1 to infinite ln y divided by y squared dy equals to 1, so that is valid. And for x, integral from 1 to infinite fx dx equal to from 1 to infinite 1 divided by 2 times x squared dx is 1 over 2. It's also valid.